One of the most fascinating astronomical events that scientists eagerly anticipate is the potential supernova of Betelgeuse. Located in the constellation Orion, it marks the prominent shoulder of the legendary hunter. Betelgeuse, often pronounced Betelgeuse, is a red supergiant star that appears to be nearing the end of its life cycle. In 2019, this well-known star unexpectedly began to dim noticeably. Its brightness decline was so stark that even people observing with the naked eye could see the change. Then, over a few months, Betelgeuse's brightness oscillated, sparking speculation about its imminent fate among astronomers and enthusiasts alike. This phenomenon, often called the Great Dimming, led astronomers to question whether Betelgeuse was on the verge of a massive explosion, known as a supernova. When Betelgeuse does eventually explode, it will mark the end of its life cycle and be a dramatic celestial event. However, questions remain. When might this happen? Why has Betelgeuse's brightness changed so dramatically? And perhaps more intriguingly, would an explosion of this magnitude have any consequences for Earth? Positioned on the upper right shoulder of Orion, Betelgeuse is also known by its other designation, Alpha Orionis, although it is technically the constellation's second brightest star after the blue supergiant Rigel. Betelgeuse remains one of the most interesting stars in the night sky for astronomers. This interest is not only due to its massive size and striking red color, but also because of its variable brightness and unusual behavior. Traditionally, alpha stars denote the brightest stars in their respective constellations. But in this case, Rigel outshines Betelgeuse in brightness, though Betelgeuse's red hue and immense size make it distinct. Betelgeuse, one of the most prominent stars visible from much of North America, Europe, and Canada, is the 10th brightest star in the night sky. The name Betelgeuse originates from Arabic, meaning armpit of the giant, referring to its position in the constellation Orion. This red supergiant star loses approximately 1 solar mass every 10,000 years, ejecting material in all directions and forming a nebula around itself with a diameter of about 30 astronomical units, roughly 30 times the distance from Earth to the Sun. Betelgeuse's nebula is 250 times larger than the star itself, a testament to its immense power and influence. At its core, Betelgeuse fuses hydrogen atoms under intense gravity, creating helium and releasing energy in the form of light and heat. As the star exhausts its hydrogen fuel, it shifts to fusing helium, which then produces carbon. This process continues, forming progressively heavier elements like neon, magnesium, silicon, and eventually iron. However, the fusion of iron does not release energy. Instead, it leads the star to collapse under its own gravitational forces. The resulting implosion will eventually culminate in a supernova, one of the most powerful explosions in the known universe. The color and brightness of a star are generally indicative of its age and stage in its life cycle. Stars emit light at different wavelengths, depending on their temperature and composition, with young stars glowing bright blue and older stars appearing red. Ancient astronomers, including the Greek astronomer Ptolemy, once described Betelgeuse's color as somewhat ruddy, indicating its red hue was evident even then. Interestingly, ancient Chinese astronomers described Betelgeuse as yellow, suggesting it may have once been a yellow supergiant before evolving into the red supergiant we see today. Massive stars like Betelgeuse consume their fuel rapidly, resulting in shorter lifespans. Although Betelgeuse is millions of years old, this is relatively young for a star. However, its rapid fuel consumption means it is nearing the end of its life. While our Sun still has around 5 billion years left, Betelgeuse may only have tens of thousands of years. If they're to remain in, its death as a supernova could happen within this period, although predicting the exact timing remains a challenge for astronomers. Betelgeuse, one of the most studied and watched stars in the night sky, is known to undergo regular cycles of brightening and dimming. One of its most notable cycles takes place approximately every 5 years and lasts for about 100 days. During these periods, the star's brightness changes significantly enough to be observed even without the aid of telescopes. This variability is primarily due to the star's outer layers expanding and contracting, a process that alters both its diameter and surface temperature. As the star expands, its outer layers cool and it appears dimmer. Conversely, when it contracts, the surface heats up and its brightness increases. This rhythmic pulsation is a characteristic behavior of red supergiant stars nearing the end of their life cycle. However, not all dimming events are regular or predictable. In late 2019 and early 2020, Betelgeuse exhibited an unusually dramatic drop in brightness one that deviated from its known cycles. This episode was so intense and prolonged that it sparked a global reaction among astronomers and space enthusiasts alike. The brightness of Betelgeuse decreased by nearly 60%, and the change was visible to the naked eye, making it a rare and captivating event for both professional and amateur stargazers because of its magnitude and timing. This unexpected dimming prompted speculation that Betelgeuse might be on the verge of collapsing into a supernova, cataclysmic explosion that marks the end of a massive star's life. Some scientists believed this could be the first warning sign of such an explosion, leading to heightened observational efforts from ground-based observatories and space telescopes, including the Hubble Space Telescope, although Betelgeuse eventually returned to its normal brightness by March 2020. The cause of the dimming remained a subject of intense study. Later investigations suggested that the event may have been the result of a massive surface mass ejection, in which the star expelled large amounts of material that temporarily obscured its light. This theory helped calm fears of an imminent supernova, but also underscored how little we still understand about the final stages of a supergiant star's life. Betelgeuse continues to be monitored closely, with scientists eager to learn more from its behavior as it marches slowly but surely toward its inevitable fate. Despite continuous observations since antiquity, the true cause of Betelgeuse's 2019 dimming episode remains a mystery. Detailed studies of the star date back to the 1st century BC, yet much remains unknown about this enigmatic star. Betelgeuse's movement through space is equally fascinating. It travels through the interstellar medium at a speed of 30 kilometers per second. Having been ejected from the Orion-Obi-Wan Association, home to the stars of Orion's belt, Betelgeuse has left an impressive trail. Its shockwave, which extends over 4 light years, is a visible testament to its journey. Determining the exact distance to Betelgeuse, like other red supergiant stars, is notoriously challenging due to numerous factors. These include its pulsating nature, which causes fluctuations in its size. The star's visual emission changes depending on the distance from its center, and as it moves away from the central core, it dims. Additionally, the circumstellar envelope material that Betelgeuse has ejected plays a crucial role in both emitting and absorbing light, which further complicates accurate brightness measurements. The variability of Betelgeuse's appearance has posed challenges to direct comparisons across observations. The star's apparent size varies based on the wavelength of light used to observe it, with its diameter fluctuating by as much as 35% across the 5 electromagnetic spectrum. In July 2009, the European Southern Observatory released images taken with a VLT interferometer, revealing a massive plume of gas, extending about 30 astronomical units from Betelgeuse's surface. This was one of several recorded mass ejections comparable in size to the distance between the Sun and Neptune. At least 6 distinct ejections have been observed around Betelgeuse, a phenomenon that might hold clues to the mysterious mass loss occurring in the final stages of supergiant stars like this one. Understanding these complex mass ejections may be key to solving the mystery of how these stars meet their ends. Although Betelgeuse's dynamic extended atmosphere is still not fully understood, advancements in interferometric technology have brought astronomers closer to unraveling its secrets. In 2019, observations from the Hubble Space Telescope and other observatories provided additional insight into Betelgeuse's recent dimming. These studies revealed that the star had ejected a significant portion of its visible surface, generating what scientists call a surface mass ejection, SME. While the Sun occasionally produces coronal mass ejections, CMEs, the SME observed on Betelgeuse was far more intense, releasing material hundreds of billions of times greater than a typical solar CME. This ejection explains the dramatic drop in Betelgeuse's brightness in late 2019. The star's luminosity dropped sharply, from magnitude 0.5 to 1.7 by mid-February 2020. At one point, Betelgeuse lost approximately 3 times its usual brightness. By February 17, 2020, the star's brightness had stabilized, and by early March, it appeared that Betelgeuse's dimming episode had subsided. Despite the visual changes, infrared observations showed no substantial changes in Betelgeuse's core temperature, suggesting that the dimming was not directly related to a core collapse. Betelgeuse's unique and enigmatic characteristics continue to captivate astronomers and astrophysicists around the world. As a red supergiant nearing the end of its stellar life, Betelgeuse offers a rare real-time glimpse into the processes that govern the final stages of massive stars. One of the most intriguing aspects of this star is its irregular and unpredictable behavior, particularly the mysterious dimming episodes that have occurred in recent years. While some changes in brightness are part of its normal pulsation cycle, others appear to be driven by far more complex and poorly understood mechanisms. Many scientists now believe that these dimming events are closely linked to the interactions between Betelgeuse's extended atmosphere and the interstellar medium in the thin matter that exists between stars and through which Betelgeuse is currently traveling. The star's outer layers are extremely dynamic, expanding and contracting, often releasing enormous amounts of gas and dust into the surrounding space. These expelled materials can cool and condense into clouds, partially obscuring the star's visible light when viewed from Earth. As Betelgeuse moves through space, this surrounding material interacts with both the stellar wind and interstellar particles, forming shock waves and dense shells of gas and dust. One key factor contributing to Betelgeuse's variability is the occurrence of surface mass ejections, SMEs, massive outbursts, during which large portions of the star's outer layers are blown into space. These events are far more powerful than the Sun's coronal mass ejections and are capable of releasing hundreds of billions of times more material. Such mass loss episodes may not only explain temporary dimming events, but also provide vital clues about the star's internal processes and future evolution. Understanding these surface mass ejections and other mass loss phenomena is crucial to unlocking the mysteries of stellar death. The material ejected by Betelgeuse helps shape the surrounding nebula and contributes to the cosmic cycle of matter, eventually forming new stars and planets. More importantly, the rate and nature of mass loss are thought to directly affect the timing and structure of the eventual supernova explosion. By studying Betelgeuse and stars like it, astronomers hope to refine models of stellar evolution and better predict how and when a red supergiant will explode. Betelgeuse, with its grand scale and volatile temperament, continues to serve as a stellar laboratory for unlocking the secrets of the universe.